right, welcome back. We're on to our third part of the lesson. We're now going to be talking about our trigonometric ratios. So basically a ratio is just when you're comparing two sides of the triangle. Last year, if you'll remember, we used the Greek letter called theta. I'll spell it out here, theta, but I'm also going to write, remember it's kind of like a cursive O right there. But here's our theta down here. Theta represents the angle that you're going to use in your right triangle. It's never going to be the right angle. It's got to be an acute angle. But just depending on where that theta is, the first thing you're going to do to find trig ratios is you're going to label the triangle. Last year we taught you 3 words. You've got to label the triangle. Everyone already knows hypotenuse. So if you just go across from your right angle, that's your hypotenuse. If you go across from theta, so across from the angle that they've identified, this is what they call the opposite side. It's always going to be across from wherever theta gets placed. And then your other side, I saved this one for the last, it's the adjacent side. All right, so every triangle is going to be labeled with those 3 words: hypotenuse, opposite, and adjacent. And then if you'll remember from last year, we had a nice acronym. It was SOHCAHTOA. And this will help us to remember which ratio matches up with which sides. So as we're going through this, remember S right here for our SO. That stands for the sine of theta. So the sine of theta here is the opposite side over the hypotenuse. The opposite over the hypotenuse. Which in our triangle over here on the left, our triangle, the opposite side right here is A. Okay, so I'm just going to go ahead and write A right there. The hypotenuse is C, so we could also say it is A over C. All right, we do the same thing for our cosine. Our cosine of the theta, so this cos stands for the cosine of theta. It is the adjacent over the hypotenuse. Okay, so the adjacent over the hypotenuse right there. So looking at our picture, our adjacent this time is our B, and our hypotenuse is still the C. So it's going to be B over C right there. On our last trig ratio, the tangent of theta is going to equal the opposite side over the adjacent side. Opposite over the adjacent. So in our drawing over here, the opposite here is A over the adjacent, which is our B. All right, so those are our main 3 trig ratios that you're going to be using this year. However, there are 3 other ones. We call them the reciprocal ratios or reciprocal functions. So the cosecant right here, the cosecant is the reciprocal of the sine. So you can see right here, it's 1 over the sine of theta. I think it's easier just to remember the reciprocal just basically switches the opposite and the hypotenuse. They just trade places. So instead of A over C, your cosecant is going to be C over A. Since A was in the top, it goes to the bottom. C is in the bottom, it goes to the top. Okay, so on all these, it's pretty easy to do. If you've found the cosine already, the secant, you just flip it. It was B over C. You're going to now make it C over B. Same thing with the cotangent. It's just going to be the reciprocal of the tangent. So you're going to put the B over A, and you're done with the cotangent there. All right, so the next couple examples are going to actually ask you to find all 6 of those trig ratios. First thing I would always start with is by labeling your triangle. Now you'll notice on this one, they've already labeled theta. Okay, they've chose that angle down there as the angle that they want you to label the triangle according to. I always label the opposite first, so I'm going to go right across from that one and call this side the opposite side. Okay, the next easy one for me to do is the hypotenuse, right across from your right angle. That's your hypotenuse, and then this last one is the adjacent. So it's your adjacent side. All right, now that we've got the triangle labeled, normally we could just go ahead and start filling in all these lovely ratios using our numbers. However, notice that they've only given you 2 sides of our right triangle. So we're going to have to go back to the first part of this lesson where we use the Pythagorean theorem. Remember, if they give you 2 sides of a right triangle, you can always find the third using your Pythagorean theorem. So we're going to call our hypotenuse C again, make sure that that's C, and just plug it into our, A and B don't matter, we'll call this A and B. So off to the side here, we've got our A squared, or 30 squared, plus 16 squared is equal to C squared. And 30 squared is 900, 16 squared is 256. That is equal to C squared. Add those together, you've got 1,156 is equal to C squared. Now, luckily, this works out to be a nice integer, nice number. If you take the square root of 1156, you get 34. So this side over here is going to be 34 right there. All right, now we're able to, I'm going to write up here our SOHCAHTOA. SOHCAHTOA. This will help us as we're going through to do all of the ratios. So we've got our triangle labeled. We found all the sides. So we're just going to look for the sine. Remember, the sine is our opposite over hypotenuse. So looking at our picture, our opposite 16, our hypotenuse is 34. So we're just going to put 16 over 34. And I am fine. If you want to simplify this, all the best to you. Okay, we could divide them both by 2 and you've got 8 over 17. And that's lovely. For this purpose, I don't really care so much about simplifying them, so I'm going to go ahead and say, let's just do the 16 over 34. Now, when I have this sign, I'm actually going to grab the cosecant as well, because remember, it just is the same sides, but just in different order. So we're just going to do the 34 over 16 and have that one done as well. All right, on to the cosine. The cosine of an angle is always the adjacent side over the hypotenuse. Okay, so in this one, our adjacent is 30, our hypotenuse is 34, and then we could go fill in the secant, which just is the reciprocal of that. So you got 34 over 30. And then our last one here, the tangent. Remember, the tangent is going to be your opposite over your adjacent. So we find our opposite here is 16 over the adjacent, which is 30. And then the reciprocal, or the cotangent, is going to be 30 over 16. Not too bad, right? All right, let's try that. Next example here. Example 4. This time you'll notice that there is no triangle drawn. I would tell you very first thing is go ahead and draw your own lovely right triangle. Make sure it's a right triangle right there. Now this time, instead of drawing the triangle, they gave us the cosine. Okay, so the cosine of my angle right here is 2 over 3. Now, remember, let's write it over here. SOHCAHTOA. So when they told us the cosine, really what they are telling us is they're telling us two sides. They're telling us the adjacent side and the hypotenuse. So if we're to draw our triangle, let's go ahead and choose an angle to be theta. I'm just going to put it down there, and I'm still going to label my triangle. Very first thing always that I do after I draw the triangle is label it. So go across from theta, that's our opposite. Across from our right angle is the hypotenuse, and that leaves this side to be the adjacent. All right, so giving us the cosine, they told us the adjacent side is 2. So I'm just going to mark that down here, that the side is 2. And they've told me the hypotenuse is 3. So I've got a 2 and a 3. Now, again, they've only given me 2 sides of this nice right triangle. So we're going to have to use our Pythagorean theorem to find the missing side. This time, make sure hypotenuse is always C. And again, it doesn't matter which one is A and B. So our A is what's missing this time. I'm just going to come off to the side, write A squared plus B, which is 2 squared, is equal to my C, or 3 squared. And then solving this, 2 squared is 4, 3 squared is 9, and I can go through and just subtract 4. So A squared is equal to 5. Then you can go ahead and take the square root of both sides. So that A side is equal to the square root of 5. All right, now we're ready just to plug everything in. Again, we know our sine is the opposite, which is my square root of 5, over the hypotenuse, which is 3. There's my nice lovely sine. Now, the reciprocal function, so my cosecant down here just switches those, 3 over the square root of 5. However, this is one of those other cases like last examples. They don't like that radical in the denominator. It's a no-no. So multiply by whatever that radical is, top and bottom. So I've got 3 times the square root of 5, or just 3 times the square root of 5, all divided by, again, these can combine. Square root of 5 times 5 is 25, but we know the square root of 25 is just plain 5. That's your cosecant. Okay? All right, the cosine. They've already given us the cosine, so we can easily fill out the secant. It's just the reciprocal, or 3 over 2. Now looking at the tangent. Tangent of theta right here is the TOA, opposite over the adjacent. Okay, so again, my opposite is the square root of 5. My adjacent is 2. So when I go to flip that, the cotangent is going to be 2 over the square root of 5. Again, don't leave that radical in the denominator. Multiply by square root of 5 over square root of 5, and you've got 2 square roots of 5 over 5. And you found all 6 of those lovely trig ratios.